Hello and welcome to the Programming in C++ series. In this video we're going to continue on with Chapter 5, which deals with Control Structures Part 2, Repetitions. Before we get started, let's go ahead and smash that like button, leave a comment, and make sure that you are subscribed to the channel. If you're already subscribed to the channel, welcome back. So if you're unable to click the like button or leave a comment, it means you're not logged in. And if you have not yet created a YouTube login, it is free and takes less than 1 minute. So please go ahead and do that so you can interact with other YouTubers. And when you subscribe to the channel, you can see when new videos are posted. So our first exercise in this video is going to be Programming in C++, Programming Exercise 520. In this exercise, when you borrow money to buy a house, a car, or for some other purpose, you repay the loan by making periodic payments over a certain period of time. Of course, the lending company will charge interest on the loan. Every periodic payment consists of interest on the loan and the payment toward principal amount. To be specific, suppose that you borrow $1,000 at an interest rate of 7.2% per year, and the payments are monthly. Suppose that your monthly payment is $25. Now the interest is 7.2% per year, and the payments are monthly. So the interest rate per month is 7.2 divided by 12 equals 0.6%. The first month's interest on $1,000 is 1,000 times 0.006 equals $6. Because the payment is $25 and interest for the first month is $6, the payment toward the principal amount is 25 minus 6, which is $19. This means after making the first payment, the loan amount is 1,000 minus 19, which equals $981. For the second payment, the interest is calculated on $981, so the interest for the second month is 981 times 0.006, which equals 5.886. That is approximately $5.89, or 5.886. That's probably approximately $589, or $5.89. This implies that the payment toward the principal is $25 minus $5.89, which is $19.11. And the remaining balance after the second payment is $981 minus $19.11 equals $961.89. This process is repeated until the loan is paid. With a program that accepts as input the loan amount, the interest rate per year, the monthly payment, enter the interest rate as a percentage. For example, if the interest rate is 7.2% per year, then enter 7.2. The program then outputs the number of months it would take to repay the loan. Note that if the monthly payment is less than the first month's interest, then after each payment, the loan amount will increase. In this case, the program must warn the borrower that the monthly payment is too low, the loan cannot be repaid. Since your program handles currency, make sure you use the data type that can store decimals with a decimal precision of 2. And then for task 1, the correct output for test cases is what will be graded on. So let's go ahead and look at our code. And before we get started, let's take a look at this. Alright, so let's go ahead and get it going. First thing we're going to need to add another include statement. So let's go ahead and do that. And we're going to add our IO manip. And we don't have any constants to declare, so let's go ahead and get our cosmetics set up and get some room to work. And let's start with declaring our variables, which since we're going to have 2 decimal places, let's make double. And the first one, let's go loan amount. Then let's do interest rate. Then interest rate per month. And monthly payment. And let's do payment principal. Right. Then we got integer. It's going to be months. So next, let's go ahead and set our precision. precision, and 2 decimal places. So we colon that. And let's start our output. We want to say enter the loan amount. And our variable is going to be loan amount. And inline. Okay. There's these. There we go. So next one. We're going to say enter the interest rate per year. And we're not going to use a decimal, we're just going to put the number as per the instructions. So which variable we're going to use with this one? Of course, it's going to be interest rate. What does it look like? Interstate interest. Let's go look at our variable. Interest. There we go. Camel code it. And then see out inline. And our output is done. So let's now do the math on our interest rate. So interest rates per month will equal, so like we did an example, was interest rate variable. Let's call that variable, divide that by 100, and then divide that by 12 because there's 12 months in a year and you're making monthly payments. So there we go. So reason why we're dividing by 100, because we're going to put, if the interest rate is 7%, we're not going to put 0.07. If we did that, that's one way to do it, but we're going to do we're going to do 7 or 7.2 as per the instructions. That's why we have to divide this by 100. And like I said, there's 12 months in a year, so then we're going to divide it by 12 because we need the interest rate on the principal every month to be accurate. All right, so with that in mind, let's do our output for this. And let's say enter. Let's go. Yeah, enter the monthly payment. And we'll use monthly payment. And we're not gonna end it just yet. So we'll do a quick if statement, because if you're paying off the principal and the interest is higher than the principal, where you never can pay off the loan as per the instructions, we want to print that out for. Let's go with monthly payment. If monthly payment is less than or equal to loan amount times interest rate 1. Okay. So this if is going to allow us to bracket over here. Brackets, enter. So we want to point out, hey look, you're never going to pay this off, man. So monthly payment is too low. The loan cannot be repaid. Then we can go ahead and line. And then let's return 1. Space return 1. That's clear, and that's it for our if statement. So we go months. Initialize that to 0. 0, 0. And then let's do a while. Loan amount. Loan amount is greater than 0. Let's bring this up. So let's see. Do a bracket for that. And so payment principal. Call that variable. Equals monthly payment minus, let's use brackets for this, loan amount times interest rate per month. Let's go ahead and semicolon that. Loan amount equal loan amount minus payment principal. Alright, and then let's increment every month. That, and that's it for the while statement. Month plus. Okay, the variable is months plus. There we go. Alright. So let's see out. It will take there's some space there. Let's use our call our variable months. And then continue the sentence with a space and then months to repay the loan. Alright, so we leave a space after because the however many months it is, this variable is going to place a digit after this space, and then it's going to skip another space, and then it's going to play months to repay. So that's why we left those blanks, of course. And then let's go ahead and here and line. Alright, let's bring up our return 0. And let's see, verify the text real quick. So line 2, we added our IO manip include statement. Then we declare our variables, our doubles. They are loan amount, interest rate per month, monthly payment, and payment principal. Then we added one integers, which is months. Then we did our set precision on line 12, 2 decimal places. Then our statements enter the loan amount with the variable loan amount, enter the interest rate per year with the variable interest rate. Then we did the math of interest rate per month equals, spelled month wrong in both of these. I'm going to correct it everywhere. Okay, nope. And I have to correct the variable because I misspelled it in the variable. Alright, declaring the variable. So that should clear those up. Alright, so monthly payment, interest rate per month equals interest divided by 100 divided by 12. Then we enter into the monthly payment. We use to call the variable monthly payment. And then if the variable monthly payment is less than or equal to loan amount times interest rate per month, the other doubles, then you're going to print out monthly payment is too low. The loan cannot be repaid. So basically your interest is going to keep that loan live for a long time until you pay more. So on down to the while loan amount is greater than 0. So if everything goes as planned, you're paying off the loan a little bit at a time. Payment principal equals monthly payment minus loan amount times interest per month. There we go. Let's that turn blue. And loan amount equals loan amount minus payment principal. and then we increment monthly, months, plus, plus, and then we print out. It will take months to repay the loan. All right, so let's go ahead and run it using our, I think we're using 7.2. Enter loan amount, so $1,000. 7.2. Pay the regular payment. Monthly payment, $25. Take 46 months to repay that loan. Just under 4 years. Alright. So now let's go ahead and calculate that, and we'll review the code for you in case you need to do more work. That looks good from the standpoint of running the program. So let's go check out that line from line 21 or 1 to 21. And our last double is payment principal. Alright, so I'll leave that there for us a few seconds. And if you need more time, go ahead and pause it. Remember, this is payment principal and semicolon at the end, of course. So let's scroll down. And that's the end of our code. Alright, so let's see what we got here as far as calculating. And we got green, and we got 100%. So if you need more time on that, go ahead and pause it. I'm going to go down one more time. Payment principal, semicolon. Alright, so let's go. Pause it as needed. If you're having trouble, a lot of times we make mistakes. Depends on how tired you are, how long you've been looking, or your typing skills or distractions. So if you made mistakes, there goes the code. Pause it as needed. As we're going to move on to the next one, but right after this. Alright, let's move on to programming in C++, programming exercise 5-21. Alright, enhance your program from exercise 20 by first telling the user the minimum monthly payments and then prompting the user to enter the monthly payment. Your last payment might be more than the remaining loan amount and interest on it. In this case, output the actual amount of the last payment. Also output the total interest paid. Alright, so we're going to add that. The good thing is that they transferred it for us, so we didn't have to copy and paste it. So it looks a little different because of our format, but everything is the same. So let's go. In order to do this, we're going to add several more variables. So let's start with how do I do this? I'll just make it down. Okay, so let's skip right here. We don't need any more include statements. Go down to line 14. Let's do double. So we're going to need a total interest amount. And we need to initialize that to 0.0. Semicolon. Another one, it's going to be double. Let's separate these so they're easy to see. Interest rate. Okay. Yeah, interest amount for the month. And let's make these, separate these. Let's see. Alright, so let's do two more. Double. Last payment, since we don't have a, initialize that to 0.0. And then minimum monthly payments. I'm going to add double to the front of that. See, I didn't do that first. So, double. Alright, minimum monthly payment. Then, let's see, let's separate these. Integers, months is going to stay the same. Our set precision is still going to be needed. We're still going to go with enter the loan amount. Enter the interest rate. And then we had our math, and then let's see, enter the moves, We got to add minimum for the math after interest rate. Let's also do minimum monthly payment. There we go. Equals loan amount times interest rate per month. Per month. So there we go. Semicolon there. Again, we're still going to use the monthly payment must be. All right, we're going to add output here. Let's go T. Let's go. The monthly payment must be more. That and a space there. So what we're going to do, and we'll call our variable, is going to be minimum monthly payment. There we go. And then in line. All right. So enter the monthly payment. That can stay the same. Here. We're not going to use this if here. Let's move this. Alright, so yeah, we need to not use this if statement here, but we might need it. Let's go highlight this, Control X. That, then we can go straight into our while. Okay, let's see what we got here. All right, we're going to nest our if inside our while statement. So let's go. Load amount is greater than 0. Payment equals. It's going to be interest. It's going to be a little bit different. So let's just go ahead and redo this one. And let's go. Start with the interest rate. So let's go interest. So, okay. I'm going to use interest amount for the month. Equals loan amount. Amount times interest rate. Interest rate per month. Alright, there we go. Now let's go payment principal. Equals monthly payment. Minus interest amount for the month. And let's go total interest amount. Equals total interest amount plus interest amount for the month. And then let's semicolon that. Now we can do our if here, if loan amount plus interest amount for the month. Month is less than monthly payments. Let's go to last payment equals loan amount. minus payment principal. All right. I think we got it. Loan amount plus interest amount per month. Okay, there we go. Now we can do loan amount equals loan amount plus interest minus principal payment. Payment principal. Can't fit the variable names, payment principal. And that's that. And then we got another months plus. And it will tell us what we need. So it will take months to pay your loan. Then we'll add our other CLs. This one will be, so we said the last payment and total interest paid. Okay. The last payment on a loan is and we'll use the variable last payment. Call the variable payment, and then we'll add line, and then we'll do skip a space for that one. Make some capitals. All right, and then it said the total interest paid is and then the variable, we'll call the variable total interest paid, total interest amount. Okay, there we go. And then let's end it. All right, looks like we're good. So we just had to add these two variables, total interest amount, initialize it to 0.0, then added another double interest amount for the month. Then we had two more doubles, last payment, initialize that to 0.0, and then added minimum monthly payment. Month interest were already there, set position was already there. Then we added minimum monthly payment equals loan amount times interest rate per month variable. Then we made the monthly payment must be more than, we added that was already there. That was already there as well. So we go down, we created a while, or we enhance our while statement. Interest amount for the month equals loan amount times interest rate per month. Payment principal equals monthly payment minus interest amount for the month. Total interest amount equals total interest amount plus interest amount for the month. Then our if loan amount plus interest amount for the month is less than monthly payment. Then last payment equals loan amount minus interest amount for the month. And then loan amount equals loan amount minus payment principal. Then we increment months again. Months plus, and we didn't do our semicolon. This time we did. All right. So let's see. Other months. Yep, we got it there. All right. Then we did our printouts. It will take months to repay the loan. The last payment of the loan is, and the total interest paid is. All right. So let's go ahead and run this. See what we get. Get more what I'm going to use, but I'm just going to try to use the same numbers as I did before. Enter loan amount $1,000. Enter interest rate 7.2. Monthly payment maybe for the monthly payment must be more than $6. Enter the monthly payment 25. All right, there's our. It will take 76 months. The last payment on the loan is $12.66. Total interest paid is $146.92. All right, so let's go ahead and calc that up. And while it's doing, we'll go ahead and get you through this. So I'm going to scroll through it slowly. You can pause as you need, as we already talked through it. So just pause it whenever you need it, if you're still working. Uh-oh, got a mistake. So let's go back and check our mistake. And it told us notify 8.5 to the lower amount of interest. Enter the interest rate. It must be more than 8.94. Is this why I didn't put the right output? So, okay, let me look at this. Okay, we did get it to run. I spelled total interest amount, that variable, wrong up here. So once I got that right, I left out the E, but I corrected that. So everything else should be fine. So I'm going to slow roll through the code. And if you need to pause it, go ahead and pause it. And there we have it. That's all for the code. So, all right, so we'll see you on the next one right after this. Programming in C++, programming exercise 5-22. This one, so we're gonna write a complete program and test the code in example 5-21. Divide it in main.cpp. All right, test one, correct output for test cases, and then the variables declared correctly. All right, so we got to do the top part this time. First thing, let's go ahead and scroll this down. Click right here where this 4 is, and just go down. Also, let's go ahead and indent this, because if we don't, everything's going to be off. So let's indent everything over at least once. One tab. So all I'm doing is clicking on front of the line and then clicking tab and did it over. Then we'll go start from the start at the very top with the include statement. Include and just IOStream and using namespace std. And then our int main. So let's go and let's go with the brackets. I'm just going to do one at the beginning and one at the end. So that's there. All right, and then just for good measures, let's go return 0. Finish. And let's go here. All right. So once we start that, we're going to need, so for I equals I and I. So one of our variables has got to be I. It looks like it's going to be an integer. The other one for J equals, so we're going to have two integers, I and J. So let's go ahead and declare our variables. Let's do that on this line here. Let's go int. Let's go int I. Int J. Alright, so we got our two variables declared. And we got our for statement. I equals 1, I less than 5, I plus plus, for J, 1, J, asterisk, and line. And that's basically all we need. So let's try to run it. Because we did our include IOStream using namespace, int main, and our two outer brackets, and our two integers I and J. That's all we needed to do. Return 0 and then close out that bracket. So let's try to run that. Print it out, but it didn't give us. Okay. So that's what we're going to do. So let's calculate it. So we got our 2 green, and I'll flash you back on the code so you can make sure you got it right. Just make sure you indented everything before, and the C out should be indented one more past the brackets, and then the C out with the asterisk is indented one more past the 4. Should be nothing on this line except for everything up top before the main. Alright, so we got task 0 and task 1 and task 2 correct, and 100%. So that is all. I'll give you a few seconds with the code. If you need more time, go ahead and pause it, as we're going to move on to the next one. So now programming in C++, programming exercise 5-23. And this one is write a complete program to test the code. An example 5-22 provided in main 22. Convert output for test cases, variables declared correctly. So the same thing. So just like we did the last time, let's go to this 4 and push it down so we have some room to work. And let's tab everything over one tab, every line, so that it lines back up correctly. And this time let's do it in reverse. Let's do our return 0 here. And then let's do our closing tab here. Alright. So let's go up to line 1 and let's add our include. And we'll do IOStream, of course. And this time let's go ahead and add our set W3. So we're gonna need our IO manip for this one. So include IO manip there, and then I'm using namespace std. Then our int main, and then our opening bracket. Alright, so we already did one at the bottom, so we don't need that second one, so let's delete that. And you should have this right here. So let's go ahead and skip a space and tab over. It already took us there. So let's declare our variables again. This time they're going to be the same as before, I and J. Comma J semicolon. Alright, put them both on the same line that time. And we got 4I equals I. That's all we need for this one. Again, looks good. Let's see if we got our right. Let's make sure we got our input, our correct output. And this time it's going to give us the numbers 1, 5, 1, 2, 3, 5, 10, 2, 4, 6, 8, count by 3, divide by 2, or time multiplied by 2. Alright, so let's go ahead and calculate that up. Looks good. And we'll get you back to code. All we did was add our 2 include statements, IOStream and IO manip, using namespace std semicolon, our main object, our main function. See. Then we clear our variables A and J. We can stand there. Got too much white space in there. Then we left everything else is, and we got our 2 green. We did our return 0 and our closeout bracket. So return 0 and both tasks are good. And we have our 100%. Alright, there's the code. If you need more time with it, go ahead and pause it, as we're going to move on to the next lesson. Next exercise, that is. This one's going to be programming in C++, programming exercise 5-24. Here, write a program to test the code in example 5-23 provided in the mains.cpp file. The program should read into each line of exp_5_23.txt file and calculate the total value for each line. In order to complete the program, you will need to declare the following variables: counter, sum, num, and end file. An example of the program output is shown below. Line 1, sum 420, 511, 0, and so on. So task 1, correct output for test cases, and task 02, file IOUs, and then correct variable declarations. All right, so we got the same thing. So this time we're going to go to counter and do our top part again. But let's go ahead and tab everything over one line at a time. Tab it all the way over, or just one time. Every line, just one tab space. Every line, make sure you get every line so you don't lose your spacing integrity. Then we can, while we're down here, we can do return 0 and our close bracket on our first tab. All right. So now let's go up top. Let's start at line 1 all the way over. All right. So we do our include statements. So we're using include. And let's do IOStream. Then include fstream. Since we're using our in file, don't forget using namespace std and our main with our one bracket. Delete the second close one because we already did that at the bottom. And then let's go to our variables. So we can do this if we want to. So the first one said counter, they're all integers. Counter, sum, num, and in file, let's do ifstream in file. Notice we don't camel case this one followed by the ifstream. Okay, so now we use our in file. Ifstream file. So yes, get our file in file dot open. Let's use that exp 5 _23 .txt and then semicolons on the outside. Okay. So let's see. Got here. Like that. So let's do a quick if statement. Yeah. Because the counter is already there. Let's go if, and then our not in file. Brackets. See out. And let's say cannot open the input file. So if you have trouble opening input file, you're going to get this, see this statement for whatever reason. The program should terminate. So return 0. Okay. And that's it for that. So let's see what I didn't do. In file. All right, let's go ahead and scroll down. So counter 0, no, that's good. Wow, less than 5, 7, 0. Something's missing here because our counts are not reading up. So let's go while here. Number 8999. Sum equals sum plus num. In file num. And we got, that's what I need here. I need a counter. Put this on top. Control X. Control V. That got that one cleared up. Now, that cleared up everything. Okay. So that looks like it's correct. Sum inline. Yeah, return 0. So it looks like everything is lined up. And this is our code. Let's go ahead and run it. Make sure it does what it needs to do. We'll get all 3. While we're waiting for that, I'll let you look at that again. There he goes, 420. Where's some things at? Output 420, 511, 0, 694, 398. Looks like we're good to go. So move out the way, and I'll show you the code. So here's line 1 and 2, or line 1 to 21. If you need more time with that, go ahead and pause it. And we're going to scroll down to the rest of the code. There we have it. And we're all greened up and we got our 100%. So that one is good. If you need more time, I'll scroll one more time, pause it as needed, as we're going to move on. Right. So that's it for that one. We're going on to our next exercise, but right after this. Programming in C++, programming exercise 5-25, and we're going to write a complete program to test the code in example 5-24. Once again, we have a code provided for us. Task 1, correct output for test cases. Test 2, file IO used, and then task 3, correct variable declarations. All right, so let's see what we got here. Once again, when we get these, let's go ahead and just indent every line over. Let's move it down first. Let's just indent every line over 1 tab. Go every line, 1 tab. Even if it's already indented, so that way we won't use our spacing and indent integrity. So wow, was that? I messed up on that one. Let's do this one twice. Looks good. So we live off here, counter. So let's keep on every line once. And as before, while we're down here, let's go ahead and do our return 0. And close tab or bracket. All right. Start at the top. These includes done, and we got to do the same to include IOStream, and then include FStream, and then using namespace std semicolon. And then our int main for our main module. Then let's do our open bracket right under that and delete the closed one because we already have it at the bottom. Let's hit our space and let's do our variables. So we need counter. What's that? So let's do counter. We'll just delete the stuff beneath if we don't need it. Counter, comma, sum, comma, num. Then we'll do our IFStream infile, and same thing as before, infile.open, and do our exp underscore 5 underscore 24 dot text txt, and semicolon out of that, and we'll do our if again, if infile, and our brackets for the if statement. Sorry. And let's do cout, did before, cannot open input file. And inline. And we'll return 0. Doesn't see it. Alright, so now we gotta go to, let's spin this up. So this space is okay. Counter equals 0. In file, num, that looks good. But while in file, no in file, so if we don't find this file pointed here, we're gonna get this cannot open message. But if we do, wow, so the sum equals 0, that looks good. Plus 99, sum. Counter plus plus, like we did last time. That looks good except for in file num. Yeah, everything looks good. Don't see anything wrong with it. No errors up top, so we're gonna go with that. So let's go ahead and run that. So we get, we'll calculate it, and we'll go. All right, so we got the same ones as before, same numbers, so that looks promising. And let's go calculate grade. And while it's calculating, let's look at the code. Got line 1 through 21. Go ahead and look at that for a few seconds. And if you need more time, go ahead and pause it as I'm going to scroll down to the second half of the code. All right, so that's it for the second half. If you need more time, go ahead and pause it. As we're going to go ahead and see, did it calculate yet? Nope, didn't get any color, still calculating. And there's our 100, and there's our 3 tasks. One more time for the full code. If you need to pause it, go ahead and pause it. As I'm going to scroll down and show you the full code one more time as we move on to our next exercise. Programming in C++. Programming exercise 5-26. This is going to be very similar. Write a complete program to test the code. Example 5-25. 5. File input output use correct output for test cases and correct variable declarations. So let's look at it as we go down. Same thing as before. Let's get it some room to work. Let's tab every line over one tab space. It's already tabbed, still take it over one tab space to maintain your margin integrity. And then while we're down here, let's go ahead and do our return 0. And then our closeout tab. Alright, let's fly to the top, do our include statements, looking at the code. Let's see, we're gonna need, of course we're gonna need our include IOStream. And we're gonna need our include fstream again. And looks like we're gonna need include string. Alright. Then let's go using namespace. std. And then our main method. Main. So let's go open bracket and delete the second one. Down, let's declare our variables again. Integer ID, sum, num, and we have a character ch right here. as well. So it's going to be a string, actually. String name. And then ifstream in file. Alright. So then our in file, open. Go to our file. exp underscore 5 underscore 25 dot txt and then semicolon. And our if statement like before. If can't get this file, and let's print out the bracket. Cannot open input file. Line and return 0 again. Then let's see, we got in file ID while in file get while get line solid 0 in file read the first chapter. In file equals num update sum equals sum plus num in file read the next chapter in file num and then name and sum is the weights, okay, in line and in file ID again processing the next line and then return 0. Okay, that looks good. That's all we need for that one. Let's go ahead and run it. Let's see if we get our desired output. Nope. One file. I didn't spell something right. That's why. There we go. Is that the right? 16 if in file. If in file. There we go. Now let's run it again. There we go. John Smith, 420 votes. Peter Gupta, 511. Buddy Friend, 74. Dr. Miller. All right. So we got that right. Let's go ahead and calculate it. And I'll show you the code again, just in case. Right. That's line 1 to 21. Our 3 include statements using namespace std and our int main. Our integers, id, sum and num, the characters, ch, string name, and ifstream in file open, and that's the file name. Yep, we got all agreed, and we've got 100%. All right, so if you need more time with that, I'll scroll down slowly. Just pause where you need to, as we're going to move on to the next exercise. All right. There you go. Programming in C++, programming exercise 5-27. Here, the conical paper cup problem. You have been given the contract for making little conical bottled water. Let's make that smaller so we can read it. Make conical cups that come with bottled water. These cups are to be made from a circular wax paper of 4 inches in radius by removing a sector of length. See figure 5-4 below. By closing the remaining part of the circle, a conical cup is made. Basically cone. Your objective is to remove this sector so that the cup is maximum volume. Write a program that prompts a user to enter the radius of the circular wax paper. The program should then open output the length of the removed sector so that the resulting cup is of maximum volume. The maximum volume. 2. Calculate your answer to 2 decimal places using 3.1419592654 for pi. Update your output with set position 2 to ensure the proper number of decimals for testing, and the correct output for the test cases is required for task 1. All right, so we get a clear start here, which is good. Let's look at our code, make it a little bit bigger so you can see it. And let's go ahead and start, but let's start right after this. All right, first thing we can do is go ahead and start complete our include statements. So let's go IO manip, and that, and we're going to need CMath, and I think that's all we need for now. And then we have a constant double called pi. We should capitalize the constant, and we're going to go all the way to decimals as they said in the instructions. 592654 and semicolon, and then one more since we're doing conical shapes. Let's do the cone volume. So void cone volume, and it's gotta be double x double n. All right, semicolon that. That's all we need for our top. So let's go ahead and do our cosmetics and get a little room to work. And then we can start declaring our double or our variables, which are going to be doubles. Let's go double. I'm trying to save a little space here. Remove sector length. Remove sector length. And wax paper rad. Radius, it should be radius. Wax paper radius. More. Double. Paper cup base radius. Rad, I think that rad. And next one. Double paper cup. Paper cup height. And paper cup volume. Let's be consistent since we're brilliant. And the waxed paper circumference. And max volume. Get in there. Yeah, that should be enough. Alright. And one more. Comma X. There. So our last variable is X. Alright. Now let's do our set position. Fixed show point. Set precision 2. Alright. And then let's do out. And let's go enter the radius of the circular wax. Circular waxed paper in inches. And we'll use the waxed paper radius variable. CLT. Space. Alright, so got a little bit smaller. Hope you can see that. Okay. So let's go down to our x variable until x equals 0.00. Set that, and then max volume. So equal 0.00. Let's remove. Removed sector. Sector length. 1. Let's make this 0.0 as well. And that 0.00. And let's go to wax. Paper circumference. This is going to be 2 times pi times waxed paper circumference. Then let's do this again. Set position 2. Course. Let's go to wow. Wow. X is less than or equal to wax paper circumference. Let's bracket that. Paper cup base. Base radius equals waxed paper circumference minus, let's go here, x and divided by 2 times pi. We'll use the capital P, capital I to reference our constant. Then let's go paper cup. Height, square root, waxed paper radius minus paper cup base. Oops. Base radius times paper cup base. Cup base radius. Alright, and then we'll semicolon behind that. Now what do we have? Okay. We have to do the volume. Paper cup ball. Volume. That's going to equal 1.0 divided by 3.0. And let's go to times pi times paper cup base radius times paper cup base radius times paper cup height. Base radius times paper cup base radius and outside times paper cup heights. Right, and let's see what else is left. Dots. Good. Let's do the if. Paper cup volume is greater than max volume. So let's do the brackets. Max volume equals paper cup volume and removed sector length equal X. Alright, there we go. Now he's got to do one more thing outside the if. So X would equal X plus 0.1. Point note plus 0.01. Alright, so we gotta return 0. Looks like we're good on this one. Nope, we gotta do our what we're gonna say. Cout. With other remove sector. And then we'll use the variable removed sector length. And we want that in inches. One more, let's do Cout max volume. Capitalize it. Volume. Okay, this one's going to be space cubic inches. Alright, everything cleared up, so it looks good. So, alright, let's look at this again. Line 1 to 21. If you need more time, pause it. We'll scroll down again. Line 23, 43. Line 35 is going to go over a little bit. Paper cup height. Line 35 is paper cup height. Alright, if you need more time, go ahead and pause it. And there you go. Here. All right, so let's go ahead and run it. Comes good. We're good. I don't know what it's going to ask me for, but we're going to reduce that. Okay. Enter range circular wax paper in inches 6. Let them remove customer 0 inches. Let's try to give it a smaller. 4. Remove sector 0 inches. Wax paper. That doesn't sound too promising. Let's go 2. Okay, let's go to a higher number. 24. Alright, let's calculate it. I don't know if it's going to work out, but let's calculate it anyway. Check our math. It's not that long. So, did something wrong. Let's see what it is. Case 1. Able to find it, or able to find a number close enough to this test case. Unable to find. Okay, next volume. So something was wrong math-wise. Let's take a look. All right, so let's see. We got to move this over one. So I'm gonna do anything big, but I think we got our here. Paper cup equals square root wax paper radius. I think I need to multiply wax paper 5, wax paper radius, paper radius, and then minus, there we go, so check that line right here. Paper cup height equals square root of wax paper radius times wax paper radius minus wax paper, or paper cup base times paper cup base. Okay, that should do our trick. Let's go, it's line 33. I'm gonna make it small again, and I'm gonna make sure it runs. Alright, so let's go 6. Yep. 0 again. Try some different numbers. 3. Still not giving me nothing different. So 24. Alright, let's calculate it again. See if I made another mistake. That's always possible. So x equals x plus 0.01. Let's calculate. Get this down. Minus. Close this up. Let's show everything. Calculate. Alright, let's check this again. Alright, so let's check out more math. And let's see, let's try this one. Wax paper circumference equals 2, so line 26. This should be radius. Wax paper radius. Let's see if I have one up here. Wax paper. Oh, I waxed. That's why. Okay. Wax paper rad. Waxed. Paper rad. There we go. Alright, and wax paper rad here. We're good to go on that. It's fine everywhere. So your little mistakes on your variables, they're easier to find at least. But make sure you got them right everywhere. Tell me you call that variable. Alright, so let's try it again. Alright. 6 inches. Alright, so let's calculate it anyway. Alright, so we don't get it right this time. We can go ahead and I'll retype it. Alright, just end up retyping it again. Seems like I got it right this time, but I'll double check. So I typed in 6, typed in that. So I'm going to calculate it, and what I do, I'll show you what I did. If you can find out what I changed, I'm going to make it smaller so you can still see it. But couldn't find anything else, so I just retyped it, and this is the code I came up with. You can take some time to look at that. I'll make that bigger for you. You didn't get it. That's line 1 through 21. Still didn't get the still didn't get 100. So yeah, I think this one's right this time. But we'll leave it like that. If you get that, forgot anything, I'm going to leave it alone. So I got for 1-21 or lines 1 through 21. Go ahead and pause it if you need more time. Then 23 to 41 or 42, line 33 and 35. I'm going to move over for you to see the end of those. If you have not got that yet, go ahead and pause it so you can get to it. And then the end of those lines are going to show paper cup base radius and paper cup height. So go ahead and pause that if you need it, and then we'll go on down to the rest of the code. Go ahead and pause it if you need more time. And if you have any comments to add, if you've seen something wrong on there, let me know, and I will get the word out. But just by looking at it, everything else, void tone volume. Okay. Moved sector length, wax paper rad, paper cup base, paper cup height, paper cup volume, wax paper circumference, wax volume, and X. So it's funny, everything did go through, it did run, but again, didn't get all the points. So like I said, I'll get back with you on that one if I find out anything, or if you find something that I missed, put it in the comments. That way we can get our C++ learners some additional help. Alright, so thanks for joining, thanks for watching the video. Matter of fact, while I'm on here, let me go through one more time, make sure I've got everything punctuated. To the radius of the circle, wax, circular wax paper in inches. But yeah, go ahead and please smash the like button, leave a comment, and go ahead and subscribe to the channel if you have not done so. If you have, thanks again for subscribing, and we'll see you on the next one as we continue to work on Chapter 5 in C++. Have a wonderful day.